everybody, welcome to our 11.4 notes that are about equations that are quadratic in form. For this section, you can use whichever method that you would like to solve your quadratics. We've learned 4 of them so far, but you can use whichever one is the best for the situation you're in, or whichever one you like the best. The equations that we're solving in this section might not start out as quadratics, but they're going to end up as quadratics. Or they may never be quadratics, but we can solve them just with the same methods. So let's talk about the 4 methods that we've learned so far. The first method that you guys learned was factoring. The advantage of factoring is it's fast, especially if you're good at factoring. Okay? The disadvantage for factoring is that it only works sometimes. It only works if it's factorable. It only works if we have rational solutions. So it only works if it's factorable. The next method that we learned was the square root property. The square root property also works really fast if it's set up right. If it's set up right, it can take a little while, or you might not be able to do it at all. Okay? So advantage would be fast if set up well. But only works if it's in that format of something squared equals something else. So it's got to be a perfect square on one side for us to use that square root property. Which brings us to completing the square, which is, what if it's not in that setup yet, but you would like to use the square root property? What you can do is complete the square. The good news completing the square is it always works, which is awesome. The disadvantage would be that it's pretty slow and pretty tedious. Okay, it's a longer process to get the answer there. And the last one is our quadratic formula, which we learned last section. And quadratic formula also always works, which is awesome. The only real disadvantage is that you have to memorize the quadratic formula, so there's some memorization there. But at the end of the day, it's up to you. You can pick whichever one of those methods you feel like is best for the situation you're in. Let's try some examples today. So our first one I have is 4 over x minus 1 plus 9 equals negative 7 over x. And we're solving for x. So this one is not a quadratic, it's actually a rational equation, but it might turn into a quadratic later. Okay, so let's see how that goes. So solving a rational equation, what you're probably going to do first is multiply by the least common denominator. My denominators are x minus 1 and x, so my LCD, my least common denominator, would be x minus 1 and x multiplied together. So I'm going to multiply every single term by x times x minus 1. I like to write it by every term so I don't forget to multiply something. And then what's going to be nice is when we simplify, it's going to work out really nicely so that we don't have anything in our denominators anymore. In the first term, the x minus 1s are going to divide out. We're just going to be left with x times 4, which is 4x. We'll still have the addition sign in the middle. We do need to multiply by the 9 by x and x minus 1. So that would be 9x times x minus 1, which would be 9x squared minus 9x. On the right side of our equation, the x's are going to divide out. And you're going to have negative 7 times x minus 1. So negative 7 times x is negative 7x. Negative 7 times negative 1 is positive 7. And now we can see it's going to be a quadratic. And I know that because I have an x squared. If I just had x's, it would be linear. But since I have x squared, it will be a quadratic, which means we need to do some sort of a quadratic method to solve it. So what I'm going to do is get it in standard form first, so then I can either factor it or use the quadratic formula. Getting it into standard form, I'm going to add 7x to both sides, and I'm going to subtract 7 from both sides. So I will have a 9x squared. I will have 4x minus 9x, which is negative 5x. Negative 5x plus 7x is positive 2x. I also will have nothing minus 7, which is negative 7, equals, on the right side, I'll have 0, because everything canceled out. Nothing factor-wise is popping out at me, so I'm going to go ahead and use the quadratic formula to solve for x. So x equals the opposite of b, so the opposite of positive 2 is negative 2, plus or minus square root of squared, 2 squared is 4, minus 4ac, minus 4 times a, which is 9, times c, which is negative 7, and it's all over 2a, so 2 times 9. Then it's a lot of simplifying from here. If you do what's inside of the square root first, 4 minus 4 times 9 times negative 7, and you type that in your calculator, what you're going to get 256. So I'm going to have x equals negative 2 plus or minus the square root of 256 all over 2 times 9, which is 18. 256 is actually a perfect square. It's 16 squared. So I can take that square root. So now I'll have negative 2 plus or minus 16 all over 18. So this is actually a rational solution. It would have factored just fine, but it didn't come easily to me, so I just went ahead and did the quadratic formula. So we are going to get two answers from here. We'll have negative 2 plus 16, which is 14. So I'll have 14 over 18, which simplifies to 7/9. I'll also have negative 2 minus 16, which would be negative 18 over 18. And negative 18 divided by 18 is negative 1. So there's two answers. X is 7/9, or x is negative 1. The next problem I have is a word problem. We hadn't seen one of those in a while, so today seemed like a good day to do it. And we've got a motion problem. So let's read first. In 1 3/4 hours, Mark rows his boat 5 miles upriver and comes back. The speed of the current is 3 miles per hour. How fast does Mark row? All right, so let's look at our information that we have here. So first thing that they tell me is in 1 3/4 of an hour, he goes upriver and back. So what I know is that 1 3/4 is the total time. So it's the time to go up river and the time to go back added together. So time to go upriver plus time to go downstream. Okay. The next thing that we know is that Mark rows his boat 5 miles upriver, and then he comes back. So we know distances. So we know that the distance each way is 5 miles. Okay. The last thing it says in our problem is that the speed of the current is 3 miles per hour. So if you guys remember those current problems where you're going upriver, the current's slowing you down. When you're going downriver, the current is speeding you up, right? So what I know is that the current's speed is 3 miles per hour, and it's saying how fast does Mark row, so we're trying to find the speed of the boat. Okay. So in general, our overall equation that we're going to be using for this is distance equals rate times time. But if you notice with this whole total time equation, I need to solve for t so that I can get back into that and actually use that 1 3/4. So solve this equation for t. I'm going to divide by r and say that t equals d over r. And then the rate is going to be different for upstream and downstream. So the rate when I'm going upstream, the current is slowing me down. So it would be boat minus current. So boat minus my current, which is 3 miles per hour. The rate when I'm going downstream is going to be faster because the current speeds you up. The rate going downstream is going to be boat plus current, or for us, that would be boat plus 3 miles per hour, since we know the current is going 3 miles per hour. Let's put all of that together and get one equation. Okay? So I'm going to start with this idea up here. 1 3/4 equals time up plus time down. So 1 3/4 equals the time to go upstream, which is going to be distance over rate. So the distance to go upstream was 5 miles, and the rate to go upstream was b minus 3. Then I'm going to add that to the time downstream, so plus that downstream time. So again, I'm distance over rate, so the distance when he's coming back is the same. It's still 5 miles. But the rate is faster because the current's speeding him up. It'll be b plus 3. And now I have a nice starting equation and I can get going. And it only has one variable, which is the variable that I want to solve for. I'm trying to solve for how fast does the boat go. I'm trying to solve for b. So let's solve. From here, you might notice it's another rational equation. My least common denominator would be b minus 3, b plus 3, and 4. So that's what I'm going to multiply by. I'm going to multiply every single thing on both sides of my equations by 4, b minus 3, and b plus 3. Okay. On the left side, what's going to happen is the 4's will cancel out, but it's in a mixed number format, and that's a little bit harder to work with. If it helps, let's put that as an improper fraction. 1 3/4 is the same thing as 7/4. And then what's going to happen is that my 4's now cancel out, and I'm going to have 7 times b minus 3 times b plus 3. And let's go ahead and start multiplying a little bit. B minus 3 times b plus 3 would be b squared. Plus 3b and minus 3b, which is going to cancel out. And then we'll also have minus 9. Okay. On the right side, let's see what happens here. In our first term, the b minus 3's are going to cancel out. So then you're going to have 4 times 5, which would be 20. And then you're also going to have a times b plus 3. In the second term, the b plus 3's are going to cancel out. So then you're going to have 5 times 4, which is still 20. But it's going to be multiplied by b minus 3. Okay, and here it's just a lot of simplifying and a lot of, it'll be good. So 7 times b squared is 7b squared. 7 times 9 is 63. Over on the right side, 20 times b is 20b. 20 times 3 is 60. 20 times b is still 20b. And 20 times minus 3 would be minus 60. And simplifying from here, 60 minus 60 would be 0. 20b plus 20b is 40b. So now I've got 7b squared minus 63 equals 40b. It is a quadratic. I know that because I have a b squared term. So I'm going to get everything on one side. I'm going to go ahead and subtract 40b to get 7b squared minus 40b minus 63 equals 0. From here, you can either use quadratic formula or you can factor. It actually does factor pretty easily, so let me show you what that looks like. To get 7b squared, I'm going to have 7b times b. To get 6